Everybody, this is page 416. We're going to get 3 pages done. So 416, 417, 418 quickly, which, running out of time, I'm going to ask you to go ahead and pause the video and then write down and then resume the video after you've written it down. So a lot of that back and forth. Here we go. Ophelia is making a square mat for a picture frame. How can she make sure the mat is a square using only a ruler? Pause, right? Here I say it. Ophelia can measure the 4 sides to check congruent. Well, the diagonals of a rectangle are congruent. And if she wobbles the bookshelf just enough and measures the diagonals with her string until the string shows that both diagonals are congruent, then she can believe that her bookshelf is in the shape of a rectangle. Next up is page 417. Miss Baker told her geometry students that anyone bringing in a picture of the flag will get extra credit. A flag with a parallelogram. Albert brought in a picture of the United States flag, and the teacher handed Albert a ruler and told him to prove the quadrilateral that contained the stars is actually a parallelogram. What are 2 ways that Albert could prove the specified quadrilateral is a parallelogram? Well, he could measure that the opposite sides to check for congruence. That'd be a parallelogram. Or he could measure the diagonals to make sure they bisect each other. Pretty smart guy. Mrs. Baker told Albert that he needed to prove that if the quadrilateral has opposite sides congruent, then the quadrilateral is a parallelogram. So we're going to use this diagram to prove the statement. Given the quadrilateral, let me zoom out and get the whole thing in there. So flag has a diagonal GL, and that's given. That means FL and GA are congruent, LA and GF are congruent. GL is congruent to GL, that's a reflexive property. So we're going to make sure we knock that one in there. Therefore, the triangle FLG is congruent to triangle AGL by side, side, side. There they are, 1, 2, and 3. Side, 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 triangle congruence. And since the triangles are congruent, the angles created by those sides must be congruent by corresponding parts of congruent triangles are congruent. So then lastly, or not lastly, second from last, then that means that with these congruent angles, then the sides that use those angles must be congruent because of the alternate interior angles converse. And then we leave this blank for 6 to put in that the quadrilateral flag is a parallelogram. Flag is a parallelogram. All right, one more. Let's go page 418 and finish this activity 5 all the way out. Zoom out, pause along the way. Here goes. Okay. Now, Miss Baker held up 2 different pieces of length of rope and a piece of chalk, and she asked her students if they could use this rope to construct a rhombus on the blackboard. Raina raised her hand and said she could construct a rhombus with the materials. Miss Baker handed Raina the chalk and rope. What did she do? Well, Raina folded each rope in half and marked their middles. Middle mark. And middle mark. And then she crossed the ropes at their middles until they made perpendicular bisectors. Then she connected the ends of the rope with chalk, and they ended up making a rhombus, something like this. All right, could the quadrilateral 1, 2, and 3 on the kite shown be squares? If the kite is not a parallelogram, no. If the kite is not a parallelogram, then the angles formed would not be congruent, and since they're not congruent, then either the entire kite is a square or none of them are squares. You guys, that has been activity 5, some properties of quadrilaterals, parallelograms, kites, etc. Thanks for watching this video. We got one more for you for this lesson, and this lesson is over, and lesson 3 is what's left. So thank you for watching. Page 419 is left for you to watch. Click on that video. I'll see you then. Bye.